Hello, welcome back. So this is a part 2 of the solution. Okay, in the part 1, I've explained to you the solution on the maximum external load that can be applied to the connection. Okay, so now after we have determined the load, and then we actually can determine the clamping force on the clamp part. So you want to know the value of the clamp part, force on the clamp part. So we use this equation: Fp equal to 1 minus C times P external load minus Fi. So 1 minus C, the joint constant, and then this is the external load, and then this is the preload, and then we get the answer. Right, so if Fp less than 0, the part is not separated. Okay, so we determine the value of Fp. So if Fp is less than 0, then the part is, we consider, is not separated. Okay, so meaning that the part is clamped together. Okay, right. So we move on to question number 3. So in the question number 3, so we actually ask about the recommendation. Okay, and then the part is being changed to the cast iron. So based on the table, so we get the modulus of elasticity of iron, cast iron, which 165 megapascal. Right. So since we have changed the material, okay, so we need to determine the stiffness constant of each part, which is stiffness constant for ball as well as stiffness constant for the clamp part. Okay, so we are not changing the ball. The ball is still the same. Okay, but we need to determine the stiffness constant. So by using this formula, Kb equal to AB times EB divided by L. So A is the area of the ball, so pi d squared over 4, and then E is a modulus of elasticity, right? And then L is the length of the clamp part. Okay, right. So and then we just substitute the value. So pi, so this is D, right, 0.05 meters, and this is the modulus of elasticity, and then L, so we get the value of Kb. And then similarly for Kp, so we so this is the formula for Kp, right? So we just substitute the value. So Ep is the modulus of elasticity of the cast iron, which is 165 Pascal. So we just substitute here, and then this is the diameter of the ball, which is 0.05 meter or 5 millimeter. Okay, right. So and then to ln 5, 0.58 L as 0.06. Okay, so D is the diameter of the ball, which is 0.005 meter. Okay, and then we just get the new the value of Kp. And then after that, we determine the joint constant, which is a C equal to Kb over Kb plus Kp, and then we get the value of C. And then this C is actually the new C. It's not the same as the previous C. Okay, so after we have determined the new C, so the recommendation for this connection is to increase the number of ball. Okay, so that's our recommendation. So after we have determined the joint constant, and then so we would like to recommend to increase the number of ball. So in order to determine the number of ball, we will move to part 3 of the solution. Okay, stay tuned.